Hey guys, and welcome to the 8th tutorial in our PyPlot course. Here we're going to cover the final graph or chart type, and this will be the histogram. We'll create and customize a simple histogram based on the PyPlot methods. So for starters, we're going to create a separate dataset for this histogram because it does represent a different kind of data. We'll talk about what kind of data it can be used to represent and where we would use it. Then we'll plot the dataset on a histogram and then customize it a little bit. Once again, we won't go over all of the customizations, but we'll cover some of the more commonly used parameters. So let's head on over to the code now. Alright, so this is where we left off last time in section 7, talking about pie charts. As per usual, we'll get started with a new cell. By the way, if at any point in time your kernel has to reset, do make sure that any datasets you're using, you want to kind of rerun those cells, and you want to make sure that you're rerunning the import of PyPlot. Otherwise, you'll not get access to all of the methods and stuff. We'll actually be ignoring the other datasets, so just make sure you have access to this, and we'll start by creating our own dataset. Okay, so histograms often look very, very similar to bar charts and can be kind of confused with bar charts sometimes. However, the purpose of using a histogram versus a bar chart is pretty distinct. A bar graph or bar chart will essentially be used to assign these values to categories. Now, those values don't necessarily represent counts. In our case, they could, but really all we did was create 3 random categories and assign random numbers to them. They don't necessarily mean anything to us until we give them meaning. Histograms, like bar graphs or bar charts, will display these bars. It will display the categories on the bottom, and it will display the numbers on the side, but they explicitly represent counts. Okay, so a histogram will actually only need one dataset rather than 2, because most of these graphs and charts need an X and Y value. Histograms actually only need one set of data, and that's just going to be the number of categories and basically the membership of those particular categories. So let's say we were doing a count of the numbers 1 through 10. So we have a big list of numbers. All of those numbers are 1 through 10, and we're just going to basically count how many times each of those numbers pop up. We could do it with a bar graph. We could kind of loop through and tally up all of the number of times each of those numbers appear and create a bar graph explicitly. But the simpler way to do it would be to use a histogram, because histograms are used to represent the count for each category. So let's do that. We'll get started by creating a histogram data set. Okay, this is essentially just going to be a big array of numbers. So what I'd recommend you do is just take a second, enter maybe 30 or so numbers. You can do more if you want. If you do less than 30, you might end up with some kind of boring data. But I'm just going to take a second to pause my recording, create an array of about 30 numbers between 1 and 10, and then we will come back and kind of plot that data. All right, I have finished creating my dataset. It's basically, again, just 30 numbers. I did the first numbers 1 through 10, so we have at least 1 in each category, although you don't have to do that. And then I just created 20 random numbers, just kind of randomly entered the keys 1 through 10. Okay, so this is pretty random as far as I can make it. And we are just going to plot that. So we'll use the plt.hist method, and that will plot a histogram. So you can see there's a bunch of parameters as per usual. We'll actually only need one input data set, though. That's again going to be our histogram data set, like so. Okay, then we can do plt.show. So most of the other graphs and charts required X and Y variables, but the way histograms work is it will automatically infer that we are gathering counts of these categories. Okay, so we'll go ahead and run that. So this is what our data looks like. This is again just kind of a distribution between the different categories. By the way, before we go any further, I should say that we're using numbers here. We don't have to. We could have used string categories, for example. Let's say, again, we had the string representations of these numbers. So a string of 1, string of 2, 3, 4, etc. That's totally fine. We can do that too. A histogram will just basically read your data. It will create a separate category for each unique value it finds, and then it will create a count or keep track of a count of each of those items. That's kind of what a histogram does. So it doesn't matter if they're numerical or if they are string values or Boolean values, etc. It just keeps track of the number of times each category appears. Okay, so in our particular case, the category is just the numbers 1 through 10. Each number is its own category. And on the left side, we have just the implicit counts of each of these items. So in this case, we have 2 1s, we have 3 2s, we have 5 3s, and so on and so forth. Okay, note how it does look a lot like a bar graph, but everything is kind of stuck together. That's a typical way of displaying a histogram. You can separate it out if you really want, but histograms typically are kind of stuck together like this. Okay, so a couple things we can do. As per usual, we should be adding labels. So we'll do plt.title. Okay, and we'll set this to just histogram. And then we'll do plt.xlabel, and that's going to be the count. Okay, and then plt.ylabel, and this will be numbers. And then we'll do 1 through 10. Okay, so we'll go ahead and run that, and that will just give us our, let's see, I did okay. So that is the problem there. Let's go up here. Did a capital instead of a lowercase. Okay, there we go. Cool, so we get the, actually, this should, I think I mixed these up. This should be the numbers, and this should be the count. There we go. Okay, that makes a lot more sense. So again, the X label is the categories, and the Y label is the count. That should not have been mixed up. Okay, there we go. That makes more sense. So our categories are, again, the numbers 1 through 10. The count is on the left-hand side, although that, again, is kind of inferred from the fact that we're using a histogram. Okay, so there are lots of customizations. We'll just go over a couple of them, as these will be kind of the more visual customizations. So one of them will be to, of course, add a color. We can do so like this using the color parameter. Again, just using a color code, red, green, blue, white, etc. I think we'll go with a nice green or something like this. Looks pretty good. Okay. Another interesting representation is to stack our data. So we can do a cumulative equal to true if we want the data not to be displayed like this, but rather to be to keep track of all of the data as we go. In fact, you know, it's easier for me to show you than try to explain in words. As you can see, this is basically adding up all of the values as we go. Okay, so this will be kind of 30 is the total number of values that we have. And then it's kind of just dividing, or rather stepping by the count of each of those categories. Okay, so that's just an interesting way of representing the histogram. We don't typically see it in this form, but it's nice to know that this is an option. It's an easy way to keep track of the total number of items in our data set as we go, because if we set cumulative equal to false, which is the default value, we don't necessarily see how many items are in the data set. We just see the distribution of each of these, each of the categories. Another thing that we might want to do is going to be to kind of scale up our data. And actually that should be scaled down. We'll do a density equal to true. And essentially what this density equal to true parameter does is, rather than keeping track of the actual count of each of the categories, it represents the count as a proportion of the whole. Okay, so if we actually go ahead and run that cell, I'll show you what I mean. So essentially, this is kind of showing the proportion, okay, or almost the percent that each of the category is taking up. So if this one category was, I believe this was 3, there were 3 ones here, that is this is 7.5% of the total number of items in that array are going to be 1s. Whereas in this case, 20% are going to be, in this case, that was a 3, I believe. Or I don't think it's quite 20%, I think it's like 18% or something like that, and so on and so forth. But basically, this is a nice way to represent each of the counts as a proportion of the total number of items in the array, is basically what I'm trying to say here. Okay, so that is pretty much all we're going to cover here. Again, if you do want to learn a bit more about histograms, definitely check out PyPlot's histogram documentation. These, again, are the parameters I find myself using the most often when I'm creating histograms, although, to be honest, most of the time I just use kind of the default histogram that tells me enough data. Okay, so when we come back, we're going to be covering the final section, final topic, and that is going to be plotting 3D data, because everything so far has only had X and Y axes. In the next section, we'll talk about X, Y, and Z axes as well. All right, so stay tuned for that. Thanks for watching. See you guys in the next one.